Hello there, our wonderful viewers on our favorite mathematics YouTube channel, Mathematics by Boozing Up. That special channel created for you and I to come together to tackle mathematics and demystify the age-long phobia often associated with this all-important subject, one topic at a time. Thanks so much for staying tuned and being consistent subscribers and viewers on this station. Please don't forget to like, share, and subscribe, and of course comment, and ultimately tune on your button so you'll be the first to know when our subsequent videos are uploaded. We are continuing today in our topic differentiation, but this time around we are looking at something completely different from what we are used to, and that is differentiation implicitly, or simply put, implicit differentiation. What do we mean by implicit differentiation? Is there explicit differentiation? Yes, of course. So all our differentiation prior to this video has been more or less, or loosely speaking, explicit. What does that mean? If you look at the previous questions, we have things like, for example, 3x squared plus 6x minus 11. This means that y is explicitly written in terms of x. Or I have, say, for example, y equals to sine 2x plus log x minus e raised to power x squared plus 5. Again, y is written explicitly in terms of x. It's as though y has been made a subject of formula in terms of x. This is the meaning of explicit. However, for implicit, we are going to have something like this on the board, which is a mixture of y and x, and either one side or both sides, in such a way that we cannot easily separate y from the x's. So we have what's called implicit differentiation, and differentiating here is very, very easy and very interesting, but can be technical. The clue is that any moment you differentiate a y function, you must instantaneously write the y dx. Let's see how this works. Question 1. Find y dx if x cubed plus y cubed minus 5xy squared equals to 8. We differentiate each time. Going further, we have differentiating x cubed. I'm going to have 3x squared, right? Now, differentiating a y cubed is just like normal differentiation. That will be called 3y squared, but instantly followed with what? A dy dx. This is implicit. So the moment you touch a y function by differentiating it, you must quickly write the y dx instantly. So I come in. Now this is like a product. This is a product. So you have 5x and then you have y squared. So here we are saying this is u, this is my v. Remember from our previous videos, product rule. So again, because of the minus, I create a bracket. So u is what? 5x. The v will be what? Times 2y. Don't forget again the y dx. That's the product rule there. This is u dv dx. Then swapping plus, this time around v is what? Y squared. Differentiate u. We're going to have simply 5. Then we close the bracket. So we have here u dv dx plus v du dx equals to, differentiate it is 0. So we have now 3x squared plus 2y squared dy dx minus the content of the bracket. All you now need to do is to simplify and bring the dy dx's together. So we have 3x squared plus 3y squared dy dx minus 10xy dy dx minus 5y squared equals to 0. That's simplification. Going further, I collect like terms in terms of dy dx. So I'm going to have 3y squared dy dx minus 10xy dy dx equals 5y squared, because it's minus, it's going to become plus there. Then minus 3x squared. At this point, I factorize my dy dx. So I have dy dx in bracket 3y squared minus 10xy equals 5y squared minus 3x squared. And finally, the y dx, which is what is required, is simply 5y squared minus 3x squared over 3y squared minus 10xy. And that is how to go by implicit differentiation. It can be a little bit tricky, as it were, apparently, but trust me, the more you attempt questions, the more the mastery or proficiency you gain. Okay, let's take just one more question to see how implicit differentiation plays out. Now, our question 2 goes thus. Find the y dx here. If 3x squared y cubed minus 2x cos y equals 4x squared sin y. Fantastic. Okay. Now again, this is clearly a matter of implicit because we cannot write or express y explicitly in terms of x. So what you need to do is to just hit the ground running by differentiating term by term. But bear in mind, once you differentiate a y function, you must instantly follow with a dy dx. For in this question, we have products. We have triple product here. 3x squared y cubed is a product. 2x cos y is a product. 4x squared sin y is also a product. So we are going to have triple product rules. So here, 3x squared is my u, here is v. 2x is my u, cos x is v. 4x squared is my u, sin y is v. So we are going to have product rules in 3 parts. So let's go. For the first one, remember the product rule is simply u dv dx plus v du dx. So we go u for the first one, 3x squared times, differentiate v here, that will be what? 3y squared. Don't forget the y dx. This is my u, this is my dv dx, plus now swap. We have v this time around, differentiate my u, that's simply 6x. That's the first product. For the second one, please have your minus and parentheses. Because the minus affects everything you're going to get in the parentheses. So again, u here is what? Cos x. Sorry, 2x rather. Now differentiating my v, that will give me times minus sin y. Remember, differentiating cos is minus sin. And because I'm differentiating the y function, I must instantly replace with what? Dy dx. Then plus cos y. Remember, this is u dv dx. Now plus v du dx, that will be what? 2. Now don't bother put the minus 2 because the minus is already outside the bracket here. So that's the left hand side. Now equals, for the right hand side, my u is 4x squared. Differentiating my v is what? Cos y. Again, because I'm dealing with the y, by differentiating, I must replace with instantly dy dx. Now plus v, my v is sin y. Differentiate u, that will be 8x. So at this juncture, we just open the brackets and go like that. So I'm going to have here 9x squared y squared dy dx plus 6x y cubed. Then I'm going to have a plus 2x sin y dy dx minus 2 cos y. Now equals 4x squared cos y dy dx plus 8x sin y. So all we need to do at this stage is to collect all the like terms in terms of the y dx on one side. So I'm going to have 9x squared y squared dy dx plus 2x sin y dy dx, then bring in minus 4x squared cos y dy dx. So we have all the dy dx's on one side, then the others are on the other side. So we have 8x sin y, then minus 6x y cube, and lastly plus 2 cos y. So at this juncture, I can say, okay, I'm going to skip a step. Dy dx is common to the 3, I factorize. So equals essentially 8x sin y minus 6x y cube plus 2 cos y, all divided by this now, 9x squared y squared plus 2x sin y minus 4x squared cos y. And that is the solution to the implicit function here. In most cases, you observe your dy dx is going to have a mixture of x and y, unlike the explicit function. And we just come to the end of this video on implicit differentiation. So in summary, to differentiate implicitly means differentiate each term. And most importantly, note that the moment you differentiate a y function, you must immediately write the dy dx term as a product. If you have any issue whatsoever with any aspect, don't hesitate to reach out via the comment section. But then I believe with much proficiency and attempting much questions, you're going to get that mastery. See you in the next video.